So let's start. So what did we discuss in the last class, Sadar? Regarding isomorphic graphs,
Yes, sir.
and regarding coloring, right? So in today's class, we are going to see Euler graph and Hamiltonian graph. So first of all, let's see what do we mean by a Euler path. Okay, there's something called as Euler path. What is that? Listen, very simple concept, but if you don't understand it, it will be complicated. Okay? So listen. So Euler path is a path which covers every edge of the graph, exactly once. A Euler path is a path which covers every edge of the graph exactly once. Okay, so what do I mean by that? For example, let me take a graph. So I'm naming this as A, this is B, this is C, this is D, this is E, this is F. Okay, I'm naming as A, B, C, D, E, F. Now, I'm drawing an edge from. Okay, this is the graph that has been given to us. Okay? So, what is a Euler path? A Euler path is a path which covers every edge of the graph exactly once. So, if anyone is asking me, if someone has given me this graph, G1, and they're asking us to write the Euler path for this graph. Okay, if someone has given this graph and they're asking us to write the Euler path for G1, then what you will write? If you're starting from A, you can start from any vertex. If I start from A dash B dash C dash D, because I will go like this from A to B, I can cover B to C. Remember, you have to cover every edge exactly once, not more than once. So A to B, then B to C, then I'm coming from C to D. Then I can go from D to E, then E to F,
and F to A,
F to A,
and A to C,
and A to C,
and C to F.
and C to F. So that covers every edge exactly once. And we have covered all the vertices. Sorry, all the edges. Okay. So a path which covers every edge of the graph exactly once is called Euler path. But that doesn't mean that every graph will have a Euler path. There can be graphs which doesn't have a Euler path. For example, if I ask you, if I give a graph G2 to you like this, if I give a graph G2 to you like this, let me draw it a little bit big. A, B, C, D, and like this. Now let's try to draw the Euler graph for this. Sorry, a Euler path for this. So I can start from A, I'll go to B. From A, I'll go to B. From B, I'll go to C. From C, I'll go to D. Now from D, either I can go to B or I can go to A.
Yes, in a C also.
Yeah, but if I go to B, then I'm not able to cover AD
A.
and AC are left out. That means for this
Yes, sir.
graph, Euler path is not possible. Okay? So what did we understand now? We understood that it is not necessary that every graph will have a Euler path. There could be graphs for which drawing a Euler path is not possible. Okay? Just make a note of this. Right.
Yes, sir.
So are they conducting in their college? So the exams that have happened so far, were they all multiple choice questions or like it will give you
Multiple choice questions.
all were multiple choice?
Yes, sir.
Okay. If there's an option, you can send me those questions after your exam and we can discuss also whether your answer is correct or
Yes,
not.
sir.
Okay. I think you have to be on camera while you're writing the exam. But if anyway it is possible to take the picture of the questions or a
Yeah,
screenshot,
I think I can take a screenshot
you
from the
can take a
laptop.
screenshot.
Yes, sir.
You can then maybe after the exam we can discuss.
Oh, okay, sir. Done, sir.
Let's take one more graph. Say I have a graph like this. A, B, C, D, E, E, F. The same question, someone has asked me to draw the Euler graph for this, to write down the Euler path for this. So I'll start from A.
Sir, it is not a Euler path graph because in B there are two paths.
Let's see. See, if I can start with A, I'll go with B. From B, I'll go with C. C, I'll go with F. F, I'll go with E. Correct? Now, like you said, if I go with B, then I'm left out with the D and D. I'm left out with these two. Okay? If I go from
Yes.
E to D, then I can go to A.
And then E2B is remaining.
E to B is left out. But understand that doesn't mean that the Euler part doesn't exist for this graph. Okay? Suppose instead of starting from A, if I start from E, I can go from E to F. I'll go from F to C. I'll go from F to C, from C to B. From B to E, I can come. I'm going from E to F, then F to C, C to B, B to A, E. From E, I'll go to D. From A, then again I'm going to B. Am I now able to cover all the edges?
Yes, sir.
So when I'm starting from vertex A, I'm left, in this case I'm left out with BE is left out. Whereas when I'm starting with E, then I'm able to cover all the edges exactly once. So this means why I took this example is I wanted you to understand here that it is also important to choose from where you want to start in this Euler path. Okay? When you have to find a Euler path, it is also important. Try from one vertex. If you're not able to get, and try from other one and see that if you're is it possible for you to find out a Euler path or not. But every time checking like this is not possible. So I'll give you a trick here. Note down this trick. The trick is the trick is that end vertices will always have odd degree. If the end vertices in a graph have odd degrees, understand that in Euler path, the end vertices will have odd degree. For example, here I have started with E. What is the degree of E here? 3, na?
Yes, sir.
And what is the degree of B? B is also an end vertex. Degree of B is also 3. So trick is that in a Euler path, the end vertices will always have odd degree. So do not start with a even degree one. So starting with A will not give you a Euler path for sure. Starting from A will not give you a Euler path because degree of A is 2. Understood? So the moment you
Yes,
see a
sir.
graph, and someone is asking you to draw a Euler path, start from a vertex which have odd degree. Okay? So the trick is that end vertices will, in a Euler path, end vertices will always have odd degree, and intermediate vertices will always have even degree. Okay? So whatever are intermediate vertices, they will have even degrees. So except for E and B, if you check, the intermediate vertices have even degree. Okay? Make a note of it.
Yes.
Have you written it down?
Yes, sir.
Good. Now, next one. Euler circuit. So what did we discuss so far? We discussed that a Euler path is a path which covers every edge of the graph exactly once. Not less than one, not more than one. And to identify a Euler path, you should know that it always starts or ends with vertex with odd degree. So far we are clear?
Yes, sir.
Good. Now next is Euler circuit. So a Euler circuit is nothing but it is a Euler path. A Euler circuit is a Euler path which is starting or in which the Euler path in which the starting vertex and ending vertex are same. Okay, the starting vertex and ending vertex both are same. So it starts from the same vertex, ends with the same vertex also. Let's take an example. So let me take a graph like this. Okay, so this is A, this is B, this is C, this is D, this is E, this is F. To understand in the Euler circuit, the property that I told you before will not apply. What's the property? The trick that I told you before will not apply. What was the trick or the property? That the Euler path always starts from a odd degree vertex.
Yes, sir. End vertices will have order
Right.
degrees.
That will not apply here because starting and ending vertex both are same, right? Just a second, I have to put my laptop on charge. So here, understand this. So the starting vertex and the ending vertex are same. Therefore, that trick will not apply here. Okay? So what we are going to do now? We are going to apply the hit and trial method. Okay? So I'm going to start with A. I'm going to start with A. I'll go with B. Then I'll cover C. So A is covered, B is covered. Then I'll go from C to D. D is done. D to E I'll go. E is done. Then I'll go from E to F. F is done. I'll go from F to C. C is done. Then I'll go from C to E. E is done. Then from E I'll go to B. Okay. E to B I'll go. So B is done. Then from B I can go to F. Okay. So F is done. BF is done. Then I'm left with just one. No? A. Just check this. Whatever I've done is correct or not. Am I able to cover all the edges or not? If I go in this order, am I able to cover all the edges or not? Just check. Okay. Starting and ending vertices are same, and every edge is covered exactly once. Correct? Every edge is covered exactly once. So that should be our answer. Just cross verify, and I'll be back in a minute.
Yeah. Yes, sir. It is
Is right?
correct. Yes, sir.
Can you think of any other path? Just maybe we can think of any other path that is possible in this graph. Let me know. It's not that only
Okay, sir.
one path or one circuit will be there. More than one circuit can also be there. Okay, I'll be back. Okay. Now next, let's see what do we mean by a Euler graph. Okay. What do we mean by? So far, what we have seen a Euler path. We understood what is a Euler path, and we understood what is a Euler circuit. The Euler path is a path in which every edge is covered exactly once. Okay. A Euler circuit is a Euler path in which starting and ending vertex both are same. Now let's see what is Euler graph. So Euler graph is a graph. It is a graph which has Euler path. Which has Euler path. So any graph in which a Euler path is possible, any graph for which you can draw a Euler path, that graph is called Euler graph. Okay? If you're able to draw a Euler path for a graph, that graph is called Euler path. Sorry, Euler graph. Okay? Understood?
Yes, sir.
Now, how to identify that a graph is a Euler graph? Okay? So every time you cannot do hit and trial method and find out a Euler path. So very simple. The moment you see a graph, if in a Euler graph, at most there will be 2 odd degree vertices. At most there will be 2 odd degree vertices. So if you see a graph and you see that there are at most 2, either there are 0 or 1 or 2 odd degree vertices, that means that graph will have a Euler. That is a Euler graph. Okay? If a graph has at most 2 odd degree vertices, that means then Euler path exists for that graph. Okay? So let me draw a graph and tell you this. So for example, they have given you a graph like this. Somebody has given you a graph like this. Okay? Somebody has given you a graph G1 like this, and they're asking you, is it a Euler graph? Is it a Euler graph? Okay. So one way to check whether it is a Euler graph is you will draw a Euler path. You will draw a line from this to this, from this to this, from this to this, from this to this. Like that, you will go on doing it, and if you find a Euler path, you can say that yes, it is a Euler graph. What is the second way? Second way is you can use this theorem. So this theorem is called as Euler theorem. Okay, this theorem has a name. This theorem is called Euler theorem. So Euler theorem says that a graph is a Euler graph if it has at most 2 odd degree vertices. So we can apply this theorem and we can say that whether it's a Euler graph or not. So let me find out the degree of each vertex. So degree of this vertex is 3. What's the degree of this vertex? Tell me, Athar.
What's
What's the degree of this vertex?
3?
3. What's the degree of this vertex? 3.
Yes, sir. 3.
What's the degree of this vertex?
3, sir. Or
2. What is for this?
Yes, sir.
What's the degree of that vertex? Simple. Just calculate how many edges are there. 1, 2, 3, 4. 4. Degree of this? 2.
Sir, that 4, I think it is 5, I think.
Oh yeah, you are right. 1, 2, 3, 4, 5. Right. 5.
That's why I was confused.
Tell me, how many vertices in this graph have odd degree vertex? Have odd degree? How many vertices have odd degrees? Tell me. My question is, how many vertices have odd degree? Very simple.
Four,
Why
sir.
are- Four?
Yes, sir.
Yeah. Since four vertices have odd degree, implies it is not a Euler graph. Okay? Because
Yes,
what is this Euler theorem saying? Euler theorem saying is that at most two odd degree vertices should be there, but we have four, so it's not a Euler graph. Understood?
Yes, sir.
Now try to check for this. Try to check for this graph,
Yes, sir.
whether graph G2 is a Euler graph or not. I'll be back in a minute.
Yes, sir.
Yeah. So tell me,
Yes, sir. It is it is
Euler graph.
you. Yes, sir.
Let's check. What's the degree of this?
2,
What about this?
3,
Sorry. What about this?
2,
This. Sorry.
2 and 3, 2,
So how many vertices have odd degrees?
2 odd decreases.
Therefore, it's a Euler graph. Correct. And once you know that it is a Euler graph, either they can ask you in the exam, especially in multiple choice question, they'll give you this graph and they'll ask you whether it's a Euler graph or if it is a handwritten exam, actual exam, then they will ask you whether the below is a Euler graph or not. If yes,
Uh,
find out the Euler graph.
Sir, it is online. 1 hour.
I'm telling you, generally I'm telling you. Okay. If it is
Yes,
an
sir.
online exam, they can ask you like whether it is a Euler graph or not. You have to say yes, no. Okay. And sometimes they can ask you whether draw the Euler path for this graph. So then you can draw it. So what did we learn so far? So far we learned what is a Euler path. Then we understood what is a Euler circuit. And then we understood what is a Euler graph. What's a Euler path? A Euler path is a path in which every edge is covered only once. Exactly once. A Euler path will have starting and ending vertex degree as odd. And intermediate vertices degree will be even. A Euler circuit is a Euler path in which starting and ending vertices both are same. Then we saw Euler graph. A Euler graph is a graph for which a Euler path is possible. The moment you see a Euler graph, how to identify, the moment you see a graph, how to identify whether it is a Euler graph or not is that it should have at most 2 odd degree vertices. This is called Euler theorem. All clear so far?
Yes, sir.
Next, let's understand what is a Hamiltonian path. Okay, with that we'll close the today's class. Hamiltonian path. What is a Hamiltonian path? A Hamiltonian path covers every vertex exactly once. In Euler path, it was every edge exactly once. There it was edge. Here it is vertex. Next, Hamiltonian cycle or Hamiltonian circuit. Same. It covers every vertex exactly once, except the first vertex, because first vertex is covered 2 times. Understood?
Yes, sir.
The last definition. Hamiltonian graph. So Hamiltonian graph is a graph that contains Hamiltonian path. A Hamiltonian graph is a graph that contains Hamiltonian path.
Yes, sir.
So if I give you a graph like this, A, B, C, D, E. Okay? So if I ask you to draw the Hamiltonian path for it, draw the Hamiltonian path for it. How can you draw? You have to cover every vertex exactly once. A, B, C, D, and E. Cover every vertex exactly once. Any questions from this? Is it clear?
Sir, yes, sir. But it is joining that E to A also, no?
No need. You don't have to cover every edge. No?
Yeah,
You just have to cover every vertex.
yes, sir.
No need to join end. If you have covered every vertex, that's fine. Any doubts?
Yes, sir. Oh, no, sir.
So Let me just check if I have any questions on this topic. Otherwise, we'll proceed. Just a second. I'm just checking for some questions if I have any questions. Acha, there is one correction in what I taught you. So a Euler graph is a graph that contains Hamiltonian cycle. It is not Hamiltonian path, Hamiltonian cycle. And same way, in the previous case, I told you that a Euler graph is a graph that contains, I told you Euler path, but it is Euler circuit. Vega change. Okay, just do that correction.
Okay, sir. Okay, I'm not finding any questions here. So I think this much, this knowledge is good. You know this much, we should be able to. Yeah, I think we covered everything, Atha. And I think also we are done with. We're also like 5 minutes are left. Yeah. So this much knowledge you should have in the graphs chapter. Okay. Yes, sir.
So you should know different types. First of all, you should know degree and vertices. Degree, what is degree, what is vertex, what is an edge, all that. You should know like different types of graphs. You have null graph, you have complete graph, you have cycle graph, you have wheel graph. You should know about matchings. There is maximal matching, minimal matching, maximum matching, perfect matching. Then you should know about coloring, right? and you should know about what is isomorphic graphs, right? And then you should know about Euler and Hamiltonian paths. Yeah. So overall, graph theory is a very interesting,
easy part.
easy chapter. It looks see, discrete mathematics is like everything looks easy, and that's why
But
students neglect it. But it is tricky also. You have to practice. If you don't practice, first of all, you should be clear with your concepts. So now that in our class you're clear with concepts, the only thing is remaining is you should be doing the practice.
practice. Yes, sir.
So if you do the practice, you'll definitely perform well. Okay. Sure.
I think in discrete mathematics, we have to understand the concept.
You should understand the concepts. See, if it is a theoretical subject, na, you can understand it one day before the exam also. You just read that text, you will understand. But discrete mathematics is not a subject that you can understand just in one day. It takes time.
Yes, sir. At least 1 week, at least. I think
Yes.
so.
It takes. Yeah, but now that I've explained you everything, and if you go through my recordings, okay, and read the notes that you have made during our class, that's more than enough for your exam.
So that in that Google Classroom, there are only 3 videos.
Because I'm not getting time to upload them. So if you remind me tomorrow morning, I'll upload it. Okay, just come on with me on Zoom call for some time, for half an hour, and I'll upload all
Okay,
the
sir.
recordings of our classes.
So then at what time, if then at what time?
Try to
possible time you
try to come at around 11 or 12.
okay, sir.
Okay, or just let's see, 11 or 12 will just for half an hour, and I'll upload all the recordings.
Okay, sir.
Okay.
Yes, sir.
Okay, and what else I wanted to tell you? Yeah, so